Welcome to the exciting world of JavaScript. In this YouTube series, we will take you on a journey from JavaScript beginner to a confident coder. Whether you're completely new to programming or looking to expand your skill set, this series is designed to provide you with a solid foundation in JavaScript. Now without further ado, let's get into the first video. So today we'll be covering variables and data types in JavaScript. Variables are containers for storing data, and data types define the nature of the data we can store. Now before we dive into coding, let's understand the concept of variables and why they're essential in programming. Variables allow us to store and manipulate data in our programs. They act as placeholders that can hold different values during the execution of our code. JavaScript provides several built-in data types that define the nature of the data we can assign to variables. Let's start by learning how to declare and assign values to variables. In this code snippet, we declare three variables: name, age, and isStudent. We assign the value John to the name variable, the value 25 to the age variable, and the value true to the isStudent variable. Notice that we use the let keyword to declare variables in JavaScript. JavaScript provides different data types for working with numbers. Let's explore a few examples. In this code snippet, we declare two variables, num1 and num2, and assign them the values 10 and 3.14 respectively. We then perform addition using the plus operator and store the result in the result variable. Finally, we use console.log to print the result, and the printed result is down here in the console. Strings are used to represent text in JavaScript. Let's see how to work with strings. In this code snippet, we declare a variable message and assign it to the value hello world. We use the length property to get the length of the string and store it in the length variable. We can access individual characters of the string using indexing, where 0, right here, represents the first character. Finally, we use console.log to print the length of the first character. Booleans represent the concept of true or false. Let's explore how to work with booleans in JavaScript. In this code snippet, we declare two variables, isLogged and isEmailVerified, and assign them to the boolean values true and false. We use console.log to print the boolean values. Arrays are used to store multiple values in JavaScript. Let's see how to work with arrays in JavaScript. In this code snippet, we declare a variable fruits and assign it to an array of fruits. We use the push method to add a new fruit to the array. We can access individual elements of the array using indexing, where 1 represents the second element. Finally, we use console.log to print the array of fruits and the second fruit. Objects are used to store key value pairs in JavaScript. Let's see how they work. In this code snippet, we declare a variable student and assign it an object containing information about a student. We can access values using keys such as name. Finally, we use console.log to print the object and the student's name. And that concludes our tutorial on variables and data types in JavaScript. We covered the basics of declaring and assigning variables and explored different data types such as numbers, strings, booleans, arrays, and objects. With this knowledge, you can effectively handle and manipulate data in your JavaScript programs. Now we're going to look at the concept of operators and expressions in JavaScript. Operators allow us to perform operations on data, while expressions are a combination of values, variables, and operators that produce a result. Now before we dive into the coding, let's understand the importance of operators and expressions in JavaScript. Operators enable us to perform mathematical, logical, and other operations on data, allowing our programs to make decisions and manipulate values. Expressions, on the other hand, are a combination of values, variables, and operators that produce a resulting value. Let's start with arithmetic operators, which are used to perform mathematical calculations in JavaScript. In this code snippet, we declare two variables, num1 and num2. and we assign them the values 10 and 3 respectively. We then perform addition, subtraction, multiplication, division, and the modulus operations using plus, minus, the asterisk, slash, and the percent operators, respectively. Finally, we use console.log to print the results. Assignment operators are used to assign values to variables. Let's see how they work. In this code snippet, we declare a variable num and assign it to the value 10. We then use assignment operators plus equals, minus equals, times equals, slash equals to modify the value of num by performing addition, subtraction, multiplication, and division operations. Finally, we use the console.log to print the updated value of num. Example would be that the equivalent of num plus equals 5 is num equals num plus 5. Comparison operators are used to compare values and return a Boolean result. Let's explore a few examples. In this code snippet, we declare two variables, num1 and num2, and we assign them the values 10 and 5 respectively. We then use comparison operators equals equals equals, not equals equals, greater than, less than, greater than or equal to, and less than or equal to compare the values of num1 and num2. The result of each comparison is stored in a variable and printed using console.log. Logical operators are used to combine and manipulate Boolean values. Let's see how they work. In this code snippet, we declare two Boolean variables, is true and is false, and we perform the logical operations using the double and the double absolute value bars, and then the exclamation point, which means not. The results are stored in variables and printed using console.log. The ternary operator provides a concise way to write conditional expressions. Let's explore an example. In this code snippet, we declare a variable age and assign it to the value 18. We then use the ternary operator, condition, question mark, value to value 2 to check if the age is greater than or equal to 18. If true, the value yes is assigned to can vote. Otherwise, the value no is assigned. The result is printed using console.log. And that concludes our tutorial on operators and expressions in JavaScript. We covered arithmetic, assignment, comparison, logical, and ternary operators, and learned how to use them effectively in our programs. With this knowledge, you could perform calculations, make decisions, and control the flow of your JavaScript code. Now we're going to talk about control flow and conditional statements in JavaScript. Control flow allows us to determine the order of execution in our programs, while conditional statements help us make decisions based on certain conditions. Now before we dive into coding, let's understand the importance of control flow and conditional statements in JavaScript. Control flow helps us control the order of execution of our code, allowing us to perform specific actions based on certain conditions. Conditional statements such as if, else, else if, and switch provide us with the ability to make decisions and execute different blocks of code based on the evaluation of conditions. Let's start with if statements, which allow us to execute a block of code if a certain condition is true. In this code snippet, we declare a variable num and assign it to the value 10. We use an if statement to check if num is greater than 5. If the condition evaluates to true, the code inside the curly braces is executed, and the message the number is greater than 5 is printed using console.log. If-else statements allow us to execute different blocks of code based on the evaluation of a condition. Let's see an example. In this code snippet, we declare a variable num and assign it to the value 3. We use an if-else statement to check if num is divisible by 2. If the condition evaluates to true, the code inside the if block is executed. Otherwise, the code inside the else block is executed. In this case, since 3 is not divisible by 2, the message the number is odd is printed. Else if statements allow us to handle multiple conditions within a series of if-else statements. Let's explore an example. In this code snippet, we declare a variable num and assign it to the value 7. We use else if statements to check multiple conditions. If the first condition, num is less than 0, evaluates to true, the corresponding code block is executed. If not, the next condition, num equals 0, is checked, and so on. In this case, since 7 is greater than 0, the message the number is positive is printed. Switch statements provide an alternative way to handle multiple conditions. Let's see how they work. In this code snippet, we declare a variable day and assign it to the value Monday. We use a switch statement to check if the value of day and execute different blocks of code based on the matching case. If none of the cases match, the code inside the default block is executed. In this case, since day is Monday, the message it's the start of the week is printed. And that concludes our tutorial on control flow and conditional statements in JavaScript. We covered if statements, else statements, else if statements, and switch statements, and learned how to use them effectively to make decisions in our programs. Now we're going to talk about loops and iteration in JavaScript. Loops are essential for executing a block of code multiple times, allowing us to automate repetitive tasks. Now before we dive into coding, let's understand the importance of loops and iteration in JavaScript. Loops provide us with a way to repeatedly execute a block of code until a certain condition is met. They save us from writing redundant code and make our programs more efficient and flexible. Let's start with the for loop, which is commonly used when the number of iterations is known in advance. In this code snippet, back in here, just made this bigger. In this code snippet, we use a for loop to iterate over a block of code 5 times. We declare the variable I and initialize it to 0, and then the loop runs as long as I is less than 5. After each iteration, I is incremented by 1. The I++ is similar to doing I plus I plus equals 1. The message iteration followed by the value of I is printed using console.log. The while loop is useful when the number of iterations is unknown and depends on a certain condition. In this code snippet, we use a while loop to iterate over a block of code as long as condition I less than 5 is true. We initialize I to 0 before the loop starts, and inside the loop, we print the message iteration followed by the value of I, and then increment I by 1. The loop continues until I becomes equal to 5. The do while loop is similar to the while loop, but it guarantees that the code block is executed at least once, even if the condition is initially false. In this code snippet, we use a do while loop to iterate over a block of code. We start by setting I to 0, and then inside the loop we print the message iteration followed by the value of I, and then increment I by 1. The loop continues as long as the condition I less than 5 is true. And that concludes our tutorial on loops and iteration in JavaScript. We covered the for loop, while loop, and do while loop, and learned how to use them effectively to control repetitive tasks in our programs. With this knowledge, you can automate processes and save time and effort. Now we're going to talk about arrays and array manipulation in JavaScript. Arrays are powerful data structures that allow us to store and manipulate collections of values. Before we dive into coding, let's understand the importance of arrays in JavaScript. Arrays provide us with a way to store multiple values in a single variable. They're versatile and widely used in programming to handle collections of data efficiently. Let's start by learning how to create arrays in JavaScript. In this code snippet, we create different arrays. The numbers array contains a sequence of numbers, the fruits array contains a list of fruit names, and the mixed array demonstrates that arrays can hold values of different types. We use square brackets to enclose the array elements, and each element is separated by a comma. Once we have an array, we can access its elements using their index positions. In this code snippet, we access specific elements of the arrays using their index positions. The first element of the numbers array has an index of 0, so numbers 0 returns 1. Similarly, fruits 1 returns the second element, which is banana, and mix2 returns the third element, which is true. We can also modify array elements by assigning new values to them. In this code snippet, we modify the first element of the fruits array by assigning the value pair to fruit0. After the modification, we print out the updated fruits array using console.log, which is down here. Iterating over arrays allows us to perform operations on each element. In this code snippet, we use a for loop to iterate over the numbers array. The loop starts at I equals 0, and as long as I is less than the length of the array numbers.length, the loop continues. Inside the loop, we print each element of the array using console.log numbers I. JavaScript provides several built-in methods for performing common array operations. In this code snippet, we demonstrate some common array operations. We use the push method to add an element 6 to the end of the numbers array, the pop method to remove the last element, and the splice method to remove an element at a specific index. In this case, we removed it at 2. Finally, we print the modified numbers array using console.log. And that concludes our tutorial on arrays and array manipulation in JavaScript. We covered array creation, accessing array elements, modifying arrays, array iteration using loops, and common array operations. With this knowledge, you have the power to store and manipulate collections of data effectively. Now, we're going to talk about functions and scope in JavaScript. Functions are powerful tools that allow us to organize our code into reusable blocks. Now, before we dive into coding, let's understand the importance of functions in JavaScript. Functions encapsulate a block of code and allow us to execute that code whenever we need it. They help us write modular and reusable code, making our programs more organized and efficient. Let's start by learning how to define and call functions in JavaScript. In this code snippet, we define a function called greet, using the function keyword. Inside the function block, we have a console.log statement that prints the statement hello world. To invoke or call the function, we simply write its name followed by the parentheses. Here, we call greet and it prints the message to the console. Functions can also accept inputs called arguments, which allow us to pass data into the function. In this code snippet, we define a new version of the greet function that takes a name argument. Inside the function, we concatenate the name with the greeting message. When we invoke the function and provide the argument John, it prints hello John to the console. Functions can also return values, allowing us to get results back from the function. In this code snippet, we define a function add that takes two arguments, a and b. Inside the function, we use the return keyword to send back the sum of a and b. When we invoke the function with the arguments 5 and 3, the return value, 8, is stored in the variable result and we print it using console.log. Now, let's understand the concept of scope in JavaScript, which determines visibility and accessibility of variables. In this code snippet, we have a variable message defined in the global scope, accessible throughout the program. We define the greet function, which prints the value of message to the console. When we call greet, it accesses and prints the global message variable. Next, we define sayHi function with a local variable name. This variable is only accessible within the function's block. When we call sayHi, it prints hi John to the console. However, if we try to access name outside the function, we get a reference error because the variable is not defined in the global scope. And that concludes our tutorial on functions and scope in JavaScript. We covered function definition and invocation, passing arguments, returning values, and understanding scope. With this knowledge, you can write modular and reusable code, making your programs more organized and efficient. Now, we're going to talk about objects and object-oriented programming in JavaScript. Objects are powerful entities that allow us to model real-world concepts and organize data into reusable structures. Now, before we dive into coding, let's understand the importance of objects in JavaScript and help us write cleaner and more maintainable code. Objects allow us to group related data and functionality together, making our programs easier to understand and modify. Let's start by learning how to create objects in JavaScript. In this code snippet, we create an object named person using the literal syntax. Inside the curly braces, we define properties such as name and age, along with a method greet that prints a greeting message. We use the this keyword to refer to the current object. This object can now hold related data and functionality. Once we have an object, we can access its properties and invoke its methods using dot notation. In this code snippet, we access the name and age properties of the person object using dot notation. We also invoke the greet method of the person object using person.greet. Constructors are special functions used to create multiple instances of an object. Let's see how they work. In this code snippet, we define a constructor function person that takes name and age as parameters and sets them as properties of the newly created object using this name and this age. We also define the greet method inside the constructor. To create object instances, we use the new keyword followed by the constructor function. This creates a new object with the specified properties and methods. We create two instances, John and Jane, each with their unique data. Inheritance allows us to inherit properties and methods from other objects. Let's explore how it works using prototypes. In this code snippet, we have a base object, animal, with a name property. We define a prototype method, sound, for the animal object. We then create a derived object, dog, that inherits from animal using object.create animal.prototype. This allows the dog object to access properties and methods of animal. We override the sound method of the dog object to make it bark. Finally, we create a myDog instance of the dog object and call its sound method, which prints woof. And that concludes our tutorial on objects and object-oriented programming in JavaScript. We covered object creation, accessing properties and methods, constructors, and the principles of inheritance. With this knowledge, you now have the power to write cleaner and more modular code using objects. Now we're going to talk about DOM, or Document Object Model, in JavaScript. The DOM is an essential part of web development, allowing us to interact with HTML elements, modify their content, and create dynamic web pages. Now before we dive into coding, let's understand the importance of the DOM in web development. The DOM represents the structure of an HTML document as a tree-like structure, with each element being a node. We can use JavaScript to access, manipulate, and update these nodes, giving us the power to create dynamic and interactive web pages. Let's start by learning how to access these elements in the DOM using JavaScript. I will preface this by saying you should have a brief understanding of how HTML works. In this code snippet, we use various methods to access elements in the DOM. The getElementById method allows us to select an element using its unique ID attribute. The getElementByClassName method selects elements based on their class name. And the getElementsByTagName method selects elements based on their tag name. These methods return a collection of elements that match the specified criteria. Once we have access to an element, we can modify its styles and content. In this code snippet, we demonstrate how to modify styles, the styles, and the content of an element. The style property allows us to change the CSS styles of an element dynamically. Here, we set the color to red and the font size to 20 pixels. The inner HTML property lets us update the content of an element. In this case, we set the content to hello world. And we get an error here because we actually don't have the element we're calling. You have to create that yourself on an HTML file. We can also handle events in the DOM, such as button clicks or keyboard inputs. In this code snippet, we attach an event listener to the click of an element. When the element is clicked, the specified function is executed, displaying an alert with the message "button clicked." This allows us to respond to user interactions and create interactive web experiences. Traversing the DOM means moving up, down, or sideways within the tree-like structure to access related elements. In this code snippet, we demonstrate basic DOM traversal methods. The parent node property allows us to access the parent element of a given element. The next element sibling property gives us the next sibling element, and the previous element sibling property provides the previous sibling element. These traversal methods enable us to navigate and interact with elements in different parts of the DOM. And here are the DOMs I was just talking about. Alright, so that's going to conclude our tutorial on working with DOMs, or Document Object Models, in JavaScript. We covered accessing elements, modifying styles and content, handling events, and DOM traversal. With this knowledge, you now have the power to create dynamic and interactive web pages. Now we're going to talk about event handling in JavaScript. Events are crucial for creating interactive web pages as they allow us to respond to user actions such as clicks, mouse movements, and keyboard inputs. Now before we dive into coding, let's understand the importance of event handling in web development. Events are actions or occurrences that happen in the browser, such as a button click or a key press. JavaScript allows us to capture and handle these events, enabling us to respond to user interactions and create interactive web experiences. Let's start by learning how to attach event listeners to elements in JavaScript. In this code snippet, we select an element with the ID myButton using getElementById. We then attach an event listener to the button using the addEventListener. The first argument specifies the event type, which in this case is click, and the second argument is a callback function that contains the code to execute when the first event occurs. JavaScript supports various event types that we can listen for. Let's explore a few of the common ones. In this code snippet, we demonstrate 3 different event types: click, mouse over, and key down. We attach event listeners to each button for each event type and provide the respective code to execute when the event occurs. Event propagation refers to how events propagate through the DOM tree. Understanding event propagation is crucial when dealing with nested elements and event handling. In this code snippet, we have a parent element and a child element inside it. We attach an event listener to the child element and use the stop propagation method to prevent the event from propagating to its parent elements. This ensures that only the code inside the event listener for the child element is executed when it's clicked. Event delegation is a technique where we attach a single event listener to a parent element to handle events for its child elements. This is useful when dynamically adding or removing elements from the DOM. In this code snippet, we attach an event listener to the parent element and use the event.target property to identify the actual element that triggered the event. We can then perform specific actions based on the target element, such as executing code when a list item li is clicked. This technique allows us to handle events for multiple child events with just a single event listener. And that concludes our tutorial on event handling in JavaScript. We covered event listeners, event types, event propagation, and event delegation. With this knowledge, you will have the power to create interactive and dynamic web experiences. Now we're going to explore asynchronous JavaScript and AJAX. Asynchronous programming is crucial for building modern web applications that can handle multiple tasks simultaneously without blocking the user interface. Now before we dive into coding, let's understand the importance of asynchronous programming and AJAX in web development. Asynchronous JavaScript allows us to execute multiple tasks simultaneously, improving the performance and responsiveness of our web applications. AJAX, or asynchronous JavaScript and XML, enables us to make requests to a server without reloading the entire page, allowing for dynamic and interactive user experiences. Let's start by exploring asynchronous JavaScript and how it works. In this code snippet, we use the setTimeout function to demonstrate asynchronous behavior. The code inside the timeout function is executed after a specified delay, in this case 2000 milliseconds, while the rest of the code continues to execute. This allows us to perform tasks in the background without blocking the execution of other code. Now, let's move on to Ajax and making asynchronous requests to a server. In this code snippet, we create a new XML HTTP request object using the new XML HTTP request constructor. We then use the open method to specify the request type, get, post, etc., and the URL of the server. The onNode event handler is triggered when the response is received, and we check if the status code is 200, indicating the successful request, and if so, we log the response text to the console. Now, once we receive a response from the server, we can handle it accordingly. In this code snippet, we parse the response text using json.parse to convert it into a JavaScript object. We then pass the data into a displayData function where we can manipulate and display it on a web page. This allows us to work with the server's response and update the user interface dynamically. Ajax requests are commonly used to interact with APIs and retrieve data from external sources. In this code snippet, we use the fetch function, a modern alternative to XML HTTP requests, to make a GET request to an API endpoint. We chain then methods to handle the response and convert it into a JSON format. Finally, we pass the data to the displayPost function to display the post on the web page. The catch method is used to handle any errors that may occur during the request. And that concludes our tutorial on asynchronous JavaScript and Ajax. We covered asynchronous JavaScript concepts, making Ajax requests, handling responses, and working with APIs. With this knowledge, you now have the power to create dynamic and interactive web pages. Now, we're going to talk about error handling and debugging in JavaScript. Errors are an inevitable part of programming, but knowing how to handle and debug them effectively is crucial for creating robust and reliable applications. Now, before we dive into coding, let's understand the importance of error handling and debugging in web development. Errors can occur for various reasons, such as incorrect input, network issues, or programming mistakes. Proper error handling allows us to gracefully handle these errors and prevent them from crashing our applications. Debugging techniques help us identify and fix errors during development. Let's start by exploring try-catch blocks, a fundamental mechanism for handling errors in JavaScript. In this code snippet, we enclose the code that may throw an error within a try block. If an error occurs within the try block, it's caught by the catch block, and we can specify the code to handle the error. The error object contains information about the error, such as the error message. JavaScript allows us to throw custom errors to indicate specific issues in our code. In this code snippet, we define a divide function that throws a custom error if the second argument is 0. We use the throw keyword followed by the error constructor to create a new error object within a specific error message. Inside the try block, we call the divide function and catch the error in the catch block. We can access these error messages using the error.message property. Logging errors is an essential part of debugging. It helps us track and analyze errors during development or when our code is in production. In this code snippet, we have a fetch data function that makes an Ajax request to an API. If the response status is not OK or 200, we throw a custom error with the response status. We use the console.log method to log the error in the catchbook. This allows us to track and investigate errors that occur during the execution of our code. Let's explore some common debugging techniques that help us identify and fix errors in our JavaScript code. In this code snippet, we use the debugger statement to set a breakpoint in our code. When the code is executed, it pauses at the breakpoint, allowing us to inspect variables, step through the code, and identify issues. We can use the borrower's developer tools to explore the call, stack, variables, and execute code line by line. And that concludes our tutorial on error handling and debugging in JavaScript. we covered try-catch blocks, throwing custom errors, logging errors, and common debugging techniques. With these skills, you'll be able to handle errors gracefully and efficiently debug your JavaScript code. Now we're going to talk about libraries and frameworks in JavaScript. JavaScript libraries and frameworks are powerful tools that provide pre-written code and functionalities to help us build web applications more efficiently. They're widely used in the industry and can significantly enhance our development workflow. Today, we'll explore the concepts of libraries and frameworks, discuss their advantages, and take a closer look at popular examples like React, Angular, and Vue.js. Now, before we dive into the code, let's quickly understand what libraries and frameworks are and why they're essential for JavaScript development. JavaScript libraries are collections of pre-written code that provide specific functionalities, making it easier to achieve common tasks in web development. On the other hand, frameworks are more comprehensive tools that provide structured approach to building applications. They include features like routing, data management, and component architecture. By utilizing libraries and frameworks, we can save time, reduce code complexity, and enhance code reusability. Our first example is React, a popular JavaScript library for building user interfaces. React uses a component-based approach to create reusable UI elements. Let's take a look at a simple React component. In this code snippet, we define a React component called greeting. It extends the React component class and has a render method that returns JSX, a syntax extension for JavaScript. We then use react.dom.render to render our greeting component inside the HTML element with the ID root. React takes care of efficiently updating the UI when the component's state changes. Now, in order to use React, you'll have to install the module and have the specific file set up. Our next example is Angular, which is a powerful JavaScript framework maintained by Google. Angular provides a complete solution for building complex web applications. Let's see how an Angular component is structured. In this code snippet, we import the component decorator from the Angular core module. We then define an Angular component called greeting component and use the decorator to specify its selector and template. The template contains HTML markup, and Angular takes care of rendering and updating the component in the application. Our final example is Vue.js, a progressive JavaScript framework for building user interfaces. Vue.js offers simplicity and flexibility, making it an excellent choice for both small and large projects. Let's explore a basic Vue.js component. In this code snippet, we use Vue.component to define a component called greeting. The component's template contains HTML markup. We then create a new Vue instance and provide the out property to specify the element that Vue.js will control, in this case, the element with the ID app. Vue.js handles rendering and the component and managing its state. And that concludes our exploration of JavaScript libraries and frameworks. We covered the basics of React, Angular, and Vue, but remember, there are many more libraries and frameworks that are available to cater to various project requirements. By incorporating these tools in your workflow, you can benefit from code reusability, increase productivity, and enhance application development.